CSIR Net, June 2024. Earth Atmospheric Ocean and Planetary Science, 702. Question 1. The acceleration due to gravity, g, at sea level 1 decreases with increasing latitude. 2. Increases with increasing latitude. 3. Remains constant at all latitudes. 4. Varies with longitude for a given latitude. Now, what do you think? The correct answer is B. Increases with increasing latitude. Let me explain why. First, remember that the Earth isn't perfectly round. It's an oblate spheroid. That means it's slightly flattened at the poles and bulging at the equator. Because of this shape, the distance from the Earth's center is greater at the equator than it is at the poles. And what happens when the distance increases? The gravitational force decreases. So, at the equator, gravity is a little weaker compared to the poles. Now, on top of that, we also have the Earth's rotation. The spinning of the Earth creates something called centrifugal force, which is strongest at the equator. This force works against gravity, making it even weaker at the equator. So, if we add it all together, gravity is lower at the equator and gets stronger as we move towards the poles, or as we increase in latitude. That's why the answer is B, because gravity increases with increasing latitude as you go from the equator towards the poles. Question 2. Which one of the following meteorite types is not derived from differentiated planetary bodies? 1. Iron meteorite. 2. Shergotite. 3. Eucrite. 4. Carbonaceous chondrite. The correct answer is D. Carbonaceous chondrite. Let me break this down. Carbonaceous chondrites are considered primitive meteorites. They haven't changed much since the early days of the solar system. That means they haven't gone through a process called differentiation, where a planetary body separates into layers like a core, mantle, and crust. These meteorites are basically made of material that's been around since the very beginning, before planets formed those layers. Now, look at the other options. Iron meteorites. These come from the core of differentiated planetesimals, which are small planetary bodies that developed layers. Shergotites. These are a type of Martian meteorite, meaning they come from the crust of Mars, which has undergone differentiation. Eucrites. These are igneous rocks that come from the crust of differentiated asteroids, specifically the asteroid Vesta. So, to sum it up, carbonaceous chondrites haven't gone through differentiation, which is why the correct answer is D. Question 3. For an earthquake, 1. The magnitude and intensity decrease with epicentral distance. 2. The magnitude and intensity increase with epicentral distance. 3. The magnitude remains unchanged and intensity decreases with epicentral distance. 4. The magnitude decreases with epicentral distance and intensity remains constant. The correct answer is C. The magnitude remains unchanged and the intensity decreases with epicentral distance. Now, let's break it down. First, magnitude is a measure of how much energy is released at the source of the earthquake. This is a fixed value for a given earthquake, no matter where you are. It stays the same, whether you're right at the epicenter or far away. On the other hand, intensity tells us how strong the shaking is at a specific location, and this changes depending on how close you are to the epicenter. As you move further away, the intensity decreases because the seismic waves lose energy as they travel through the Earth's crust. So, to sum up, the magnitude stays the same, but the intensity decreases as you move away from the epicenter, which is why option C is the correct answer. Question: which one of the following is the slowest hillslope process? 1. Mudflow. 2. Landslide. 3. Earthflow. 4. Solifluction. So, which one do you think is the correct answer? The right answer is 4. Solifluction. Let me explain why. Solifluction is a slow process where saturated soil gradually moves down a slope due to the force of gravity. You'll often find this happening in places with permafrost or in areas that have a lot of moisture. When the upper layer of soil thaws, it becomes mobile and starts to flow over the frozen layer below. Now, let's compare this to the other options. Mud flow is much faster. It's a quick movement of water-saturated soil and debris rushing down a slope. Landslide can also happen quickly, involving the sudden and often dramatic movement of rock and soil down a slope. Earth flow is another relatively fast process. It involves the flow of saturated soil, but it typically moves faster than solifluction. So, when we put it all together, solifluction is indeed the slowest hill slope process out of all the options provided. Question: if the density, pressure and temperatures of any air parcel and its surrounding environment are R parcel, P parcel, T parcel, and RENV, PNV, TNV respectively, when will the air parcel have a positive buoyancy? Is it A. R parcel less than RENV, B. R parcel greater than RENV, C. T parcel less than 10V, or D. P parcel greater than PNV? The correct answer is A. R parcel less than RENV. Let's break this down. Buoyancy is all about whether an object, or in this case, an air parcel, can float or rise in a fluid like the atmosphere. For an air parcel to have positive buoyancy, it needs to be less dense than the surrounding air. When the density of the air parcel, R parcel, is less than that of the surrounding environment, RENV, the air parcel will rise because it is lighter compared to the surrounding air. Now, let's look at the other options. B. R parcel greater than RENV. This indicates negative buoyancy, meaning the air parcel will sink. C. T parcel less than TNV. While this option suggests that the air parcel is cooler, it doesn't necessarily determine buoyancy. A cooler air parcel can still be less dense than warmer air. D. P parcel greater than PNV. This option also doesn't directly indicate buoyancy. Pressure alone doesn't determine if an air parcel will rise or sink. So, the key takeaway is that for positive buoyancy, the air parcel must have a density that is less than that of its environment. That's why option A is the right choice. Question 6. Scale height is the vertical distance over which the reference pressure changes to which of its original value? 1. E. 2. Square root of E. 3. 1 over E. 4. 1 over the square root of E. The answer is 3. 1 over E. The scale height is a concept from atmospheric science that defines the vertical distance over which atmospheric pressure decreases by a factor of 1 over E. Now, E is Euler's number, approximately 2.718. Mathematically, the pressure P at a height h is related to the surface pressure P0 by the equation P of h equals P0 times E to the power of negative h over h, where h is the scale height. This means after rising by one scale height, the pressure will be 1 over E times its original value, or about 36.8% of its value at the reference level. Question 7. With increasing climate warming, the open ocean regions are expected to become 1. Eutrophic, due to higher organic matter degradation at the surface. 2. Oligotrophic, due to higher consumption of nutrients by plankton due to increasing temperature. 3. Eutrophic, due to higher entrainment and mixing. 4. Oligotrophic, due to higher thermal stratification and reduced mixing. The answer is 4. Oligotrophic, due to higher thermal stratification and reduced mixing. As climate warming progresses, the open ocean is expected to experience increased thermal stratification. This means the upper layers of the ocean become warmer and less dense, causing reduced vertical mixing between surface and deeper waters. Normally, Vertical mixing helps bring nutrients from deeper waters to the surface, where they can be used by phytoplankton for growth. When mixing is reduced, fewer nutrients reach the surface, leading to oligotrophic conditions, low nutrient levels, and lower biological productivity. This nutrient limitation at the surface reduces the ability of marine ecosystems to sustain primary production, resulting in a less productive ocean, particularly in open water regions. Therefore, the warming climate will likely cause many open ocean areas to become oligotrophic due to the reduced mixing and nutrient supply. The solubility of biogenic silica in seawater. A. Decreases with temperature and salinity. B. Increases with temperature and salinity. C. Decreases with temperature and increases with salinity. D. Increases with temperature and decreases with salinity. The correct answer is D. Increases with temperature and decreases with salinity. The solubility of biogenic silica in seawater is influenced by both temperature and salinity. As temperature increases, the solubility of biogenic silica also increases because warmer water can dissolve more silica. However, with higher salinity, the solubility of silica decreases. This is due to the fact that an increase in the concentration of dissolved salts in seawater competes with silica for dissolution. Therefore, in environments with higher temperatures and lower salinity, biogenic silica tends to dissolve more easily, making option D the correct choice. Question 9. North Pacific. Deep water has higher nutrient content, higher sum CO2, and lower dissolved O2 than that in the North Atlantic because A. It is the farthest along deep circulation path. B. Of existence of more volcanoes along the margins of Pacific. C. Of larger area of the Pacific Ocean. D. Of deeper water depths of the Pacific Ocean. The correct answer is A. It is the farthest along deep circulation path. The deep waters of the North Pacific have a higher concentration of nutrients, higher total dissolved carbon dioxide, some CO2, and lower dissolved oxygen compared to the North Atlantic because of their position in the global ocean circulation. The North Pacific deep water is at the end of the deep circulation path of the global thermohaline conveyor belt. As water travels through this circulation, it picks up nutrients from the ocean floor and organic matter, while oxygen is gradually depleted through respiration processes. This makes the North Pacific waters more nutrient-rich and have lower oxygen levels. Hence, option A is the correct answer. Question 10. Planetary albedo depends on A. Amount of solar radiation reflected back to space by atmosphere. B. Amount of solar radiation reflected back to space by land surface of Earth. C. Amount of solar radiation reflected back to space by ocean surface. D. Amount of solar radiation reflected back to space by atmosphere, oceans, and land. The correct answer is D. Amount of solar radiation reflected back to space by atmosphere, oceans, and land. Planetary albedo is the measure of how much solar radiation is reflected back into space by the Earth as a whole. This reflection comes from multiple components: the atmosphere, which includes clouds and aerosols; the land surface, particularly ice and snow-covered regions, which reflect a large portion of sunlight; and the ocean surface, which also reflects some sunlight, though it is generally lower compared to land and ice. All these factors combined contribute to the overall albedo of the planet. Therefore, option D is correct, as it accounts for the reflection from the atmosphere, oceans, and land. Question 11. Which one of the following shows an ascending order of mixed layer depth in the oceanic regions? A. Subtropical Pacific Ocean, Bay of Bengal, Polar Oceanic Region. B. Polar Oceanic Region, Subtropical Pacific Ocean, Bay of Bengal. C. Bay of Bengal, Polar Oceanic Region, Subtropical Pacific Ocean. D. Bay of Bengal, Subtropical Pacific Ocean, Polar Oceanic Region. The correct answer is D. Bay of Bengal, Subtropical Pacific Ocean, Polar Oceanic Region. The mixed layer depth or MLD, varies across different oceanic regions due to factors such as temperature, salinity, wind, and surface currents. Here's the correct ascending order of MLD. 1. Bay of Bengal. It has the shallowest mixed layer due to significant freshwater input from rivers, which creates strong stratification and limits mixing. 2. Subtropical Pacific Ocean. The mixed layer here is deeper than the Bay of Bengal, but not as deep as in polar regions. This is because of consistent winds and stable temperature gradients, allowing for moderate mixing. 3. Polar Oceanic Region. Polar regions generally have the deepest mixed layer due to cold temperatures and strong winds, which enhance vertical mixing. Thus, option D correctly represents the ascending order of mixed layer depth, starting from the shallowest, Bay of Bengal, to the deepest polar oceanic region. At a depth of 900 millimeters in a sedimentary core, the carbon-14 activity is 1/16 of the surface activity. What is the average sedimentation rate, given that the carbon-14 half-life is 6,000 years? Is it A. 0.05 millimeters per year, B. 0.01875 millimeters per year, C. 0.0035 millimeters per year, or D. 0.0375 millimeters per year? The correct answer is D. 0.0375 millimeters per year. To solve this, we use the concept of radioactive decay and the relationship between depth and sedimentation rate. Step 1. Decay of carbon-14. The activity of carbon-14 decreases by a factor of 2 with each half-life. If the activity is reduced to 1/16 of the surface activity, we can express this reduction as 1/16 equals 1/2 to the power of 4. So, the sample has undergone 4 half-lives. Step 2. Calculate the age. Since the half-life of carbon-14 is 6,000 years, the total time, or age, for 4 half-lives is 4 times 6,000, which equals 24,000 years. Step 3. Determine the sedimentation rate. Given that the depth is 900 millimeters, we can calculate the sedimentation rate using the formula. Sedimentation rate equals age divided by depth, which is 24,000 years divided by 900 millimeters, equaling 0.0375 millimeters per year. Thus, the correct sedimentation rate is 0.0375 millimeters per year, making option D the correct answer. Question 13. The process by which sediment grains, moved by wind or water, jump or hop along the surface is known as A. Deflation, B. Suspension, C. Drag, or D. Saltation. The correct answer is D. Saltation. Saltation is the specific term used to describe the process where sediment grains are transported by wind or water in a series of short leaps or hops along the surface. This occurs when the force of the wind or water is strong enough to lift the grains off the surface for a brief moment, after which they fall back to the ground, often landing further downstream or downwind. Deflation refers to the removal of loose, dry, and fine particles from the land surface, often leading to the lowering of the ground level. Suspension is the process by which smaller particles are carried in the air or water over long distances without touching the ground. Drag refers to the resistance experienced by particles as they move through a fluid, be it air or water, but does not specifically describe the jumping motion. Thus, the correct answer is option D, saltation, as it accurately describes the hopping movement of sediment grains along the surface. Question 14. Grain size distribution in a flash flood deposit is likely to be A. Unimodal, B. Bimodal, C. Trimodal, D. Multimodal. Correct answer D. Multimodal. Flash floods are characterized by rapid changes in water flow and sediment transport. During such events, a variety of sediment sizes can be mobilized and deposited simultaneously. This results from the varying flow velocities in different parts of the floodplain, which can transport both fine and coarse materials. Unimodal grain size distribution means there is a single dominant size of grains. Bimodal suggests two distinct sizes of grains. Trimodal indicates three different sizes of grains. However, in a flash flood scenario, the mix of sediment sizes from both the fine particles, like silt and clay, to larger particles, like sand and gravel, is common. Consequently, this leads to a multimodal distribution, as the deposit will likely contain multiple size classes of grains. Therefore, the correct answer is option D, multimodal, reflecting the complex nature of sediment transport and deposition during flash floods. Question 15. An imaginary line representing the first appearance of a particular metamorphic index mineral in the field is called an 1. Isopleth 2. Index line 3. Isograd 4. Isofaces line. Correct answer 3. Isograd. An isograd is defined as a line on a geological map that connects points where the same metamorphic index mineral appears for the first time. These minerals serve as indicators of specific pressure and temperature conditions during metamorphism. Isograds are important in understanding the metamorphic history of a region and can help delineate different metamorphic zones. Isopleth refers to a line on a map connecting points of equal value, commonly used in various fields, but not specifically for metamorphic minerals. Index line is not a standard geological term. It does not specifically refer to the appearance of metamorphic minerals. Isofaces line refers to lines connecting areas that exhibit the same faces, but again, it does not specifically pertain to the first appearance of index minerals. Thus, the correct answer is option 3, isograd, as it accurately describes the concept in the context of metamorphic geology. Question 16. Which one of the following minerals is not a part of the Bowen's discontinuous reaction series? 1. Olivine 2. Amphibole 3. Enstatite 4. Andesine. Correct answer 4. Andesine. Bowen's reaction series describes the order of mineral crystallization from a cooling magma. It is divided into two branches, the discontinuous reaction series and the continuous reaction series. The discontinuous reaction series includes minerals that change from one form to another as temperature decreases. This series consists of olivine, pyroxene, including enstatite, amphibole, biotite. In this series, as temperature drops, olivine transforms into pyroxene, like enstatite, which then changes into amphibole and finally into biotite. Andesine, however, is a type of plagioclase feldspar and is part of the continuous reaction series, which involves a gradual change in composition rather than distinct mineral changes at specific temperatures. Thus, the correct answer is option 4, andesine, as it does not belong to the discontinuous reaction series described by Bowen. Question 17. Which one of the following defines the steady state of materials in the ocean? 1. Inputs from rivers equal the particle flux out of the euphotic zone. 2. Concentration does not change with time. 3. The removal flux must be proportional to the original amount. 4. The river input equals the atmospheric input. Correct answer 2. Concentration does not change with time. In the context of oceanography, a steady state refers to a condition where the concentrations of materials, like nutrients, sediments, or pollutants, remain constant over time. This means that the inputs and outputs of these materials are balanced, leading to no net change in concentration. Option 1 discusses a specific balance, but is more focused on particle flux rather than overall material concentration. Option 3 implies a proportional relationship between removal flux and original amount, which might not necessarily define a steady state in all contexts. Option 4 refers to specific sources of input, but does not address the overall concept of concentration stability. Thus, the correct answer is option 2. Concentration does not change with time, as it captures the essence of steady-state conditions in oceanic systems. A cuboidal rock sample is subjected to purely shear stresses. Assuming an elastic regime, the change in volume of the rock sample is 1, 0, 2, proportional to bulk modulus, 3, proportional to Young's modulus, 4, proportional to shear modulus. The correct answer is 1, 0. When a material is subjected to pure shear stress in an elastic regime, it experiences a change in shape, but no change in volume. Shear stress causes the deformation of the rock, but because it doesn't involve any compressive or tensile forces, the overall volume remains the same. This is characteristic of elastic shear deformation. The bulk modulus is related to changes in volume under uniform pressure, which is not relevant in this case. Young's modulus measures tensile or compressive strain, not shear strain. The shear modulus describes the material's response to shear stress, but it doesn't govern volume change, just the degree of shape deformation. As famously said by Isaac Newton, for every action, there is an equal and opposite reaction, and in this case, shear stress deforms the shape of the rock but leaves its volume unchanged. Thus, the correct answer is option 1, 0. Question. If the Earth were to orbit around the Sun at twice its present distance, without any change in its rotational velocity, then a year on it would have 1. 365 days. 2. 365 square root of 2 days. 3. 730 days. 4. 730 square root of 2 days. The correct answer is 4. 730 square root of 2 days. According to Kepler's third law of planetary motion, the square of the orbital period t, the time it takes to complete one orbit, is proportional to the cube of the semi-major axis of its orbit. T squared is proportional to a cubed. If the Earth were to orbit at twice its current distance from the Sun, the new semi-major axis would be twice a. Applying Kepler's law, t squared is proportional to 8a cubed. This means t equals the square root of 8t, which simplifies to 2 square root of 2t. Since a year at the current distance is 365 days, the new orbital period would be 2 square root of 2 times 365 days. Calculating t sides bts equals 730 square root of 2 days. Therefore, the correct answer is indeed option 4, 730 square root of 2 days. Question. Which among the following seismic phases is never a first arrival? 1. PG. 2. P star. 3. PMP. 4. PN. The correct answer is 3. PMP. In seismology, seismic phases refer to the different waves generated by an earthquake as they travel through the Earth. The phases listed in the question include PG. This is the seismic wave that travels through the crust. It is typically one of the first arrivals detected by seismographs. P star. This is a type of phase that can also be a first arrival, especially in certain geological conditions. PMP. This phase represents the reflected P wave from the MOHO, the boundary between the Earth's crust and the underlying mantle. Since it is a reflection, it cannot be a first arrival because it travels to the MOHO and then back to the surface, which means it will always arrive after the direct P wave phases. PN. This is the seismic phase that travels through the upper mantle and is typically a first arrival at greater distances from the earthquake source. Thus, the correct answer is option 3, PMP, as it is never a first arrival due to its nature as a reflected wave. Question. Which one of these statements is not true for till? 1. Transported en masse by glacier. 2. May have deformation features such as folds. 3. Cannot be used to infer regional ice movement. 4. Are poorly sorted deposits. The correct answer is 3. Cannot be used to infer regional ice movement. Till is a type of sediment that is directly deposited by glacial ice and is characterized by a mix of particle sizes, from clay to boulders, resulting in a poorly sorted deposit. Here's a breakdown of each statement, transported en masse by glacier. This is true. Till is indeed moved as a mass of debris by the advancing and retreating ice of glaciers. May have deformation features such as folds. This is also true. As glaciers move and push the till, it can exhibit various deformation features, including folds. Cannot be used to infer regional ice movement. This statement is not true. In fact, the characteristics of till, including its composition and orientation, can provide valuable information about past glacier movement and the direction of ice flow. Geological studies often use till to infer patterns of glacial activity and regional ice movement. Are poorly sorted deposits. This is true. Till is known for being poorly sorted due to the way sediments are mixed and deposited by glaciers. Thus, the correct answer is option 3. Cannot be used to infer regional ice movement, as this statement is indeed false regarding the properties of till. Question 22. Which of the following is not true in the context of El Niño? 1. Weakening of the Walker circulation. 2. Surface pressure decreases at Tahiti and rainfall increases eastward over the central equatorial Pacific Ocean. 3. The surface water off Western South America is colder than normal. 4. The thermocline deepens in the eastern Pacific Ocean. The correct answer is 3. The surface water off Western South America is colder than normal. El Niño is a climate phenomenon characterized by the periodic warming of ocean surface temperatures in the central and eastern tropical Pacific Ocean. Here's a breakdown of each statement. 1. Weakening of the Walker circulation. This is true. During El Niño, the Walker circulation is weakened, which affects wind patterns and ocean currents. 2. Surface pressure decreases at Tahiti and rainfall increases eastward over the central equatorial Pacific Ocean. This statement is true as well. During El Niño, lower pressure systems develop over the central Pacific, leading to increased rainfall in that region. 3. The surface water off Western South America is colder than normal. This statement is not true during El Niño. In fact, one of the hallmark features of El Niño is the warming of surface waters off the coast of Western South America. Normally, upwelling of cold, nutrient-rich water occurs in this region, but during El Niño, this upwelling is suppressed, resulting in warmer surface temperatures. 4. The thermocline deepens in the eastern Pacific Ocean. This is true. During El Niño, the thermocline becomes deeper in the eastern Pacific, affecting nutrient distribution and marine life. Thus, the correct answer is option 3. The surface water off Western South America is colder than normal, as this statement does not accurately describe conditions during El Niño. Question 23. Which one of the following sequences shows the correct order of their first appearance in the geological record since Precambrian? 1. Land plants, amphibians, Ediacaran biota. 2. Ediacaran biota, land plants, amphibians. 3. Land plants, Ediacaran biota, amphibians. 4. Ediacaran biota, amphibians, land plants. The correct answer is 2. Ediacaran biota, land plants, amphibians. The geological record provides a timeline of the appearance of various life forms. Here's a brief overview of the order of appearance for each of the groups listed. 1. Ediacaran biota. This group represents some of the earliest complex multicellular life forms and appeared during the late Precambrian period, specifically around 635 million years ago. 2. Land plants. The first land plants appeared during the Ordovician period, around 470 million years ago. These were primitive plants that marked the colonization of land. 3. Amphibians. Amphibians evolved later, during the Devonian period, around 370 million years ago. They are considered the first vertebrates to adapt to life on land. Putting this timeline together, the correct order of first appearance in the geological record is Ediacaran biota during the Precambrian, land plants during the Ordovician, and amphibians during the Devonian. Thus, the correct answer is option 2, Ediacaran biota, land plants, amphibians. Sphalerite is amphibians. Sphalerite is a major source of 1. Zinc, 2. Copper, 3. Aluminium, 4. Iron. The correct answer is 1. Zinc. Sphalerite is a mineral composed primarily of zinc sulfide, ZNS, and is the most important ore for extracting zinc. Here's a brief overview of the options. 1. Zinc sphalerite is indeed the primary source of zinc, which is used in various applications including galvanizing steel, producing alloys, and in the manufacture of batteries. 2. Copper. While there are minerals that are sources of copper, sphalerite is not one of them. 3. Aluminium. Sphalerite does not contain aluminum and is not a source for this metal. Bauxite is the primary ore for aluminum. 4. Iron. Sphalerite does not contain significant amounts of iron. Iron ores include hematite and magnetite. Thus, the correct answer is option 1, zinc, as sphalerite is a major source of this essential metal. LCL, EL, and LFC stand for lifting condensation level, equilibrium level, and level of free convection. Which of the following situations is not possible in our Earth's atmosphere? 1. LCL equals 900 HPa, EL equals 400 HPa, LFC equals 850 HPa. 2. LCL equals 850 HPa, EL equals 300 HPa, LFC equals 800 HPa. 3. LCL equals 800 HPa, EL equals 400 HPa, LFC equals 900 HPa. 4. LCL equals 900 HPa, EL equals 450 HPa, LFC equals 800 HPa. The correct answer is 3. LCL equals 800 HPa, EL equals 400 HPa, LFC equals 900 HPa. To understand which situation is not possible, let's review the definitions of the terms. 1. Lifting condensation level, LCL, the height at which air becomes saturated when lifted adiabatically, forming clouds. This level is typically at a higher pressure, lower altitude, than the equilibrium level. 2. Equilibrium level, EL, the height at which an ascending air parcel becomes denser than its surroundings and thus stops rising. This level is always above the LCL. 3. Level of free convection, LFC, the height at which an air parcel becomes warmer than its surroundings and rises freely. The LFC is generally below the EL and above the LCL. Based on these definitions, let's analyze each option. 1. LCL equals 900 HPa, EL equals 400 HPa, LFC equals 850 HPa. Possible. LCL is below LFC and LFC is below EL. 2. LCL equals 850 HPa, EL equals 300 HPa, LFC equals 800 HP. Possible. LCL is below LFC and LFC is below EL. 3. LCL equals 800 HPa, EL equals 400 HPa, LFC equals 900 HPa. Not possible. Here, LFC is above LCL and EL, which contradicts the expected order. LCL less than LFC less than EL. 4. LCL equals 900 HPa, EL equals 450 HPa, LFC equals 800 HPE possible. LCL is below LFC and LFC is below EL. Thus, the situation that is not possible in Earth's atmosphere is option 3. LCL equals 800 HPA, EL equals 400 HPA, LFC equals 900 HPA. If the Earth starts rotating in the opposite direction on its axis with the same period of rotation, then how will the length of day and night be affected at a particular place on the Earth's surface? Say Delhi. 1. Length of the day becomes longer but night shorter. 2. Length of the night becomes longer but day shorter. 3. There will be no significant change in the length of day and night. 4. Lengths of the day and night both become shorter significantly. The correct answer is 3. There will be no significant change in the length of day and night. If the Earth were to rotate in the opposite direction, from east to west instead of west to east, several effects would be observed, but the fundamental nature of the day-night cycle would remain unchanged. Here's a breakdown of the reasoning. 1. Length of the day becomes longer, but night shorter. This is incorrect. The period of rotation, 24 hours, would not change, so the duration of day and night would not change either. 2. Length of the night becomes longer, but day shorter. This is also incorrect for the same reason. The rotation period would still be 24 hours, just in the opposite direction. 3. There will be no significant change in the length of day and night. This is correct. Although the direction of the sunrise and sunset would be reversed, with the sun rising in the west and setting in the east, the actual duration of day and night would remain the same at approximately 12 hours each, assuming no other changes in axial tilt or orbit. 4. Lengths of the day and night both become shorter significantly. This is incorrect. The rotation period remains 24 hours, so there would be no significant shortening of either day or night. In conclusion, while the direction of the sun's movement across the sky would change, the length of the day and night would remain approximately the same. Therefore, the correct answer is option 3. There will be no significant change in the length of day and night. Question 27. If the green, red, NIR, and SWIR bands of the LIS-S2 sensor were designated as 1, 2, 3, and 4, respectively, then which of the following band combinations would render a standard false color composite, FCC? 1. 1 to blue, 3 to green, 4 to red. 2. 2 to blue, 3 to red, 4 to green. 3. 1 to red, 2 to green, 3 to blue. 4. 1 to blue, 2 to green, 3 to red. The correct answer is 4. 1 to blue, 2 to green, 3 to red. In remote sensing, a false color composite, FCC, is created to help visualize different features in the imagery, particularly vegetation and water bodies, by using non-visible light bands in combination with visible bands. Typically, in an FCC, the near-infrared NIR band is assigned to the red channel, enhancing vegetation contrast. The red band is assigned to the green channel. The green band is assigned to the blue channel. Given the designations from the LIS-2 sensor band 1, green, band 2, red, band 3, NIR, band 4, SWIR. For a standard FCC, we want band 1 green to blue, band 2 red to green, band 3 NIR to red. Thus, the correct band combination for a standard FCC is 1 to blue, 2 to green, 3 to red, which corresponds to option 4. Option 1, 1 to blue, 3 to green, 4 to red. This combination does not follow the FCC format correctly. Option 2, 2 to blue, 3 to red, 4 to green. This combination is incorrect. Option 3, 1 to red, 2 to green, 3 to blue. This combination does not create a standard FCC. Therefore, the correct answer is option 4, 1 to blue, 2 to green, 3 to red. Which one of the following is the correct sequence of products of increasing weathering of orthoclase? 1. Illite, kaolinite, hematite. 2. Kaolinite, illite, hematite. 3. Kaolinite, illite, gibbsite. 4. Illite, kaolinite, gibbsite. The correct answer is 4. Illite, kaolinite, gibbsite. The weathering of orthoclase, which is a potassium feldspar, generally proceeds as follows. First, illite. In initial weathering processes, orthoclase can break down into illite, which is a clay mineral. Illite is often formed from the alteration of feldspars under specific conditions. Second, kaolinite. With continued weathering, illite can further decompose to form kaolinite, particularly in conditions where the pH is lower, leading to further alteration. And third, gibbsite. Under conditions of extreme weathering, especially in highly leached tropical environments, kaolinite can alter to gibbsite. Gibbsite is indicative of advanced weathering. Thus, the correct sequence in terms of increasing weathering of orthoclase would be illite, kaolinite, gibbsite, making option 4 the correct answer. Question 29. Which of the following is a false statement about the subtropical jet stream? 1. They form over subtropical high-pressure systems at a height of about 12 kilometers. 2. They satisfy geostrophic balance. 3. They are westerly winds. 4. They are stronger in the winter hemisphere as compared to the summer hemisphere. The correct answer is 2. They satisfy geostrophic balance. Let's analyze each statement. First, they form over subtropical high-pressure systems at a height of about 12 kilometers. True. The subtropical jet stream does form in association with subtropical high-pressure systems, and its altitude can range around 10 to 15 kilometers. Second, they satisfy geostrophic balance. False. While the subtropical jet stream does exhibit characteristics similar to geostrophic flow, it is influenced by other factors such as thermal wind balance and the presence of Rossby waves. Thus, it does not strictly satisfy geostrophic balance in all cases. Third, they are westerly winds. True. The subtropical jet stream consists of westerly winds, blowing from west to east. And fourth, they are stronger in the winter hemisphere as compared to the summer hemisphere. True. The subtropical jet stream is indeed stronger during the winter months due to greater temperature gradients. So, the false statement is option 2. They satisfy geostrophic balance. Question 30. The pH of the ocean water and river is 8 and 4, respectively. What would be the dominant dissolved inorganic carbon species in the ocean and river, respectively? 1. CO2 and CO32. 2. HCO3 and CO32. 3. HCO3 and CO2. 4. CO2 and HCO3. The correct answer is 3. HCO3 and CO2. To understand the dominant dissolved inorganic carbon species in ocean and river waters, we need to consider the effects of pH on the carbon species equilibria. The main forms of dissolved inorganic carbon, DIC, in water include carbon dioxide, CO2, bicarbonate, HCO3, and carbonate, CO32, which are in equilibrium based on the following reactions. CO2 plus H2O equals H2CO3, which equals HCO3 plus H+, which equals CO32 plus 2H+. Ocean water, pH 8. At a pH of 8, the equilibrium favors bicarbonate, HCO3, and carbonate, CO32, species. The predominant species will be bicarbonate, HCO3, which is the dominant form of DIC. River water, pH 4. At a much lower pH of 4, the equilibrium strongly favors carbon dioxide, CO2. The predominant species will be carbon dioxide, CO2, due to the high concentration of H+ ions shifting the equilibrium to the left. Putting it together, in the ocean, pH 8, the dominant species is bicarbonate, HCO3. In the river, pH 4, the dominant species is carbon dioxide, CO2. Thus the correct answer is option 3, HCO3 and CO2. Question 31. The Ekman layer in the atmosphere has the following three-way force balance between 1. Pressure gradient force, Coriolis force, and centrifugal force. 2. Pressure gradient force, Coriolis force, and turbulent drag force. 3. Pressure gradient force, centrifugal force, and turbulent drag force. 4. Coriolis force, centrifugal force, and turbulent drag force. The correct answer is 2. Pressure gradient force, Coriolis force, and turbulent drag force. The Ekman layer is a concept in fluid dynamics that describes the layer of the atmosphere, or ocean, in which the effects of the Earth's rotation and friction, or drag, significantly influence the movement of air or water. In this layer, a balance of forces is established among, first, pressure gradient force, PGF. This force results from differences in pressure and drives the movement of air or water from high to low pressure. Second, Coriolis force. This is the apparent force caused by the Earth's rotation, causing moving objects to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. It influences the direction of flow. And third, turbulent drag force. This force arises from frictional interactions between the moving fluid and the surface, or other layers of fluid, acting to slow down the flow. In the Ekman layer, these three forces interact to establish the characteristic spiral flow that is seen in the layer. Thus, the correct answer is option 2, pressure gradient force, Coriolis force, and turbulent drag force. Question 32. What is the typical dip amount of unroofing joints? 1. 0 to 15 degrees. 2. 75 to 90 degrees. 3. 25 to 40 degrees. 4. 30 to 45 degrees. The correct answer is 75 to 90 degrees. Unroofing joints, also known as exfoliation joints, typically form due to the release of pressure as overlying material is removed. These joints can exhibit a steep dip, often approaching vertical orientations, 75 to 90 degrees. This range indicates a nearly vertical orientation, which is common for unroofing joints due to the stress release and mechanical processes associated with erosion. Other options: 0 to 15 degrees. This range is too flat for unroofing joints, which typically show more significant dips. 25 to 40 degrees. While these angles are common in various geological features, they are not representative of unroofing joints. 30 to 45 degrees. Similar to the previous option, these angles are not steep enough for the typical dip observed in unroofing joints. Thus, your correction is appreciated. The correct answer is indeed option 2, 75 to 90 degrees. Question 33. Domestic wastewater with gross fecal coliform contamination is called 1. Grey water. 2. Black water. 3. Red water. 4. Brown water. The correct answer is black water. Black water refers to wastewater that contains human waste, or feces, and is typically associated with toilet waste. It is characterized by high levels of pathogens, including fecal coliform bacteria, due to its content. Definitions of other options. Grey water. This is wastewater generated from non-toilet sources, such as sinks, showers, and washing machines. It typically does not contain significant fecal contamination. Red water. This term is not commonly used in the context of domestic wastewater. It may refer to wastewater containing high iron content, but is not standard terminology. Brown water. While this term is sometimes used informally to describe wastewater, it is not a standard term in wastewater management and does not specifically indicate fecal contamination. Thus, the correct answer is option 2, black water. Question 34. In which one of the following towns does the magnetic needle in a dip circle? In which one of the following towns does the magnetic needle in a dip circle deviate the most from the horizontal? 1. Thiruvananthapuram. 2. Tirupati. 3. Ujjain. 4. Lucknow. The correct answer is option 4, Lucknow. The magnetic dip or inclination varies based on geographic location relative to the magnetic poles. Generally, the dip is steeper at higher latitudes and less pronounced near the equator. Lucknow is located further north compared to the other options, which typically results in a greater magnetic dip due to its proximity to the magnetic poles. Reviewing the other locations. 1. Thiruvananthapuram, located in southern India, is closer to the equator, resulting in a shallower magnetic dip. 2. Tirupati, also in the southern region, experiences a less significant dip compared to Lucknow. 3. Ujjain, while Ujjain has some dip, it is not as pronounced as in Lucknow. Thus, the correct answer is indeed option 4. Lucknow, where the magnetic needle in a dip circle deviates the most from the horizontal. Question 35. Moving towards the Sun from outer space, the correct order of appearance of the following celestial objects or fields is 1. Heliopause, Oort cloud, Kuiper belt, asteroid belt. 2. Oort cloud, Kuiper belt, heliopause, asteroid belt. 3. Oort cloud, heliopause, Kuiper belt, asteroid belt. 4. Kuiper belt, Oort cloud, asteroid belt, heliopause. The correct answer is option 3. Oort cloud, heliopause, Kuiper belt, asteroid belt. Firstly, the Oort cloud is indeed the outermost region of our solar system, consisting of icy bodies and located far beyond the Kuiper belt. Secondly, the heliopause marks the boundary where the solar wind from the Sun slows down and interacts with the interstellar medium. It lies beyond the Oort cloud. Thirdly, the Kuiper belt is located beyond Neptune's orbit, containing many small icy bodies. It lies closer to the Sun than the Oort cloud, but is often thought of as an extension of the solar system's outer limits. Lastly, the asteroid belt is located between Mars and Jupiter and is the innermost of these regions, significantly closer to the Sun than the Kuiper belt. So, the correct order from outer space towards the Sun is Oort cloud, heliopause, Kuiper belt, asteroid belt. Thus, the correct answer is indeed option 3. Oort cloud, heliopause, Kuiper belt, asteroid belt. Question 36. The horizontal wind in small-scale vortices such as tornadoes follows: 1. Geostrophic wind balance. 2. Cyclostrophic wind balance. 3. Inertial wind balance. 4. Gradient wind balance. The correct answer is option 2. Cyclostrophic wind balance. Cyclostrophic wind balance occurs when the pressure gradient force and the centrifugal force are in balance. In small-scale vortices like tornadoes, the high wind speeds and tight pressure gradients lead to a situation where the centrifugal force becomes significant compared to the Coriolis force, allowing for this balance to occur. Overview of the other options. 1. Geostrophic wind balance is typically found in large-scale atmospheric flows, where the Coriolis force balances the pressure gradient force. It is not applicable to small-scale vortices. 2. Inertial wind balance occurs when the inertial force is balanced with the pressure gradient force, but it is not the primary balance in tornadoes. 3. Gradient wind balance includes both the pressure gradient force and the Coriolis force, making it more relevant to larger-scale weather systems rather than the small-scale winds in tornadoes. Thus, the correct answer is option 2, cyclostrophic wind balance. Question 37. Compared to the epicenter of a shallow focus earthquake, the epicenter of a deep focus earthquake lies: 1. At the same level. 2. Deeper by not more than 30 kilometers. 3. Deeper than 30 kilometers, but shallower than 700 kilometers. 4. Deeper than 700 kilometers. The correct answer is option 1, at the same level. The epicenter refers to the point on the Earth's surface directly above the focus, or hypocenter, of an earthquake. Regardless of whether an earthquake is classified as shallow, generally less than 70 kilometers deep, or deep greater than 300 kilometers deep, the epicenter itself is always at the same level on the Earth's surface. The focus, or hypocenter, refers to the actual location within the Earth where the earthquake originates, and this is where the difference in depth applies. However, when discussing the epicenter, we are talking about the surface location, which does not change with depth. Summary of the other options. 1. At the same level is correct, because the epicenter is always a point on the Earth's surface, irrespective of the depth of the earthquake. 2. Deeper, by not more than 30 kilometers, is incorrect as it implies a change in the epicenter's vertical position. 3. Deeper than 30 kilometers, but shallower than 700 kilometers is misleading because it conflates depth with the actual position of the epicenter. 4. Deeper than 700 kilometers is also incorrect as it relates to the focus and not the epicenter's position on the surface. Thus, the correct answer is option 1, at the same level. Question 38. In orgeat, how many oxygen atoms of each SiO4 tetrahedron are shared with other tetrahedra? Is it 0, 2, 1, or 4? The correct answer is 2. In the structure of orgeat, which is a type of pyroxene, each SiO4 tetrahedron shares 2 oxygen atoms with adjacent tetrahedra. This sharing contributes to the formation of a double-chain structure characteristic of the pyroxene group. The tetrahedral units are linked together in such a way that they form chains. Each tetrahedron shares 2 of its 4 oxygen atoms with neighboring tetrahedra, leading to a stable structure. Now, let's summarize the other options. 0 is incorrect. Some oxygen atoms are shared. 2 is correct. Each tetrahedron shares 2 oxygen atoms with neighboring tetrahedra. 1 is incorrect. Only 1 oxygen atom is not shared. 4 is incorrect. Not all oxygen atoms are shared. Thus, the correct answer is option 2. In which of the following oceanic zones does the highest sediment deposition take place? Is it the continental rise, continental slope, shelf break, or mid-oceanic ridge? The correct answer is the continental rise. The continental rise is the area at the base of the continental slope where sediments accumulate. It is characterized by a gentle slope and receives significant amounts of sediment from the continental shelf and slope through processes like turbidity currents. This zone acts as a transition between the continental and deep ocean floors, facilitating substantial sediment deposition. In comparison, the continental slope is steeper than the rise and has some sediment accumulation, but not as much as the rise. The shelf break is the transition from the continental shelf to the continental slope. While sediments are present, they are less than in the rise. The mid-oceanic ridge is primarily associated with volcanic activity and not significant sediment deposition compared to the continental rise. To summarize the other options, the continental rise is correct. It is where the highest sediment deposition occurs. The continental slope is incorrect. Although sediment is deposited here, it is less than the rise. The shelf break is incorrect. It is a transition zone, and sediment deposition is not maximized. The mid-oceanic ridge is incorrect. This area is more associated with volcanic and tectonic activity rather than sediment deposition. Thus, the correct answer is option 1, continental rise. Which of the following types of ore deposits are not formed by magmatic or magmatic hydrothermal processes? Is it Sudbury-type nickel-copper deposits, Bushveld-type chromite deposits, ironstone deposits, or porphyry-type copper deposits? The correct answer is ironstone deposits. Ironstone deposits are typically sedimentary in origin and are formed through processes such as the deposition of iron-rich minerals in sedimentary environments, often influenced by biological activity and the chemical precipitation of iron oxides. They do not form as a result of magmatic or magmatic hydrothermal processes. In contrast, Sudbury-type nickel-copper deposits are formed by magmatic processes related to the cooling of mafic to ultramafic intrusions. Bushveld-type chromite deposits are formed from the crystallization of chromite in layered intrusions related to magmatic processes. Porphyry-type copper deposits are associated with hydrothermal processes related to the cooling of magmatic bodies, commonly found in volcanic arcs. To summarize the other options, Sudbury-type nickel-copper deposits are incorrect. These are formed by magmatic processes. Bushveld-type chromite deposits are incorrect. These are also formed by magmatic processes. Ironstone deposits are correct. These are sedimentary and not formed by magmatic processes. Porphyry-type copper deposits are incorrect. These are formed by magmatic hydrothermal processes. Thus, the correct answer is option 3, ironstone deposits. Mass of water vapor per unit mass of dry air is called what? Is it specific humidity, mixing ratio, relative humidity, or vapor pressure? The correct answer is mixing ratio. The mixing ratio is defined as the mass of water vapor in a given mass of dry air. It is typically expressed as grams of water vapor per kilogram of dry air. This ratio helps in understanding the amount of moisture present in the air relative to the dry air. In comparison, specific humidity refers to the mass of water vapor per total mass of moist air, including both dry air and water vapor, and is also expressed in grams per kilogram. Relative humidity is a measure of how much water vapor is present in the air, compared to the maximum amount of water vapor the air can hold at a specific temperature, expressed as a percentage. Vapor pressure is the pressure exerted by the water vapor in the air, which contributes to the total atmospheric pressure. To summarize the other options, specific humidity is incorrect. It includes the mass of dry air plus water vapor. Mixing ratio is correct. It is the mass of water vapor per unit mass of dry air. Relative humidity is incorrect. It is a percentage measure of moisture relative to saturation. Vapor pressure is incorrect. It is the pressure exerted by water vapor, not a mass ratio. Thus, the correct answer is option 2, mixing ratio. Which one of the following radioisotopes has the highest half-life? 1. Thorium-232. 2. Uranium-235. 3. Uranium-238. 4. Thorium-234. The correct answer is option 1, Thorium-232. Thorium-232 has the longest half-life of approximately 14.05 billion years, making it the radioisotope with the highest half-life among the options provided. In comparison, Uranium-238 has a half-life of about 4.468 billion years. Uranium-235 has a half-life of about 703.8 million years. Thorium-234 has a very short half-life of approximately 24.1 days. To summarize the other options, Thorium-232 is correct and has the longest half-life at about 14.05 billion years. Uranium-235 has a shorter half-life at about 703.8 million years. Uranium-238 has a shorter half-life at about 4.468 billion years. Thorium-234 has a very short half-life at about 24.1 days. Thus, the correct answer is option 1, Thorium-232. The term mineralization in the marine carbon cycle refers to the process where 1. Elements that have passed through the food web are recycled. 2. Inorganic minerals are formed biologically. 3. Inorganic minerals are incorporated into the food chain. 4. Dissolution of biologically formed minerals at the sediment-water interface. The correct answer is option 1. Elements that have passed through the food web are recycled. Mineralization is a critical process in the marine carbon cycle where organic matter, such as dead organisms and waste, is broken down into inorganic forms. This process involves the transformation of complex organic materials into simpler inorganic compounds, allowing nutrients to be recycled back into the ecosystem, breaking down the options. Option 1 is correct. This option accurately describes mineralization, emphasizing the recycling of elements that have already been utilized in the food web. Option 2, inorganic minerals can be formed biologically, but this is typically referred to as biomineralization, not mineralization. Option 3, incorporation into the food chain is more related to the process of assimilation rather than mineralization. Option 4, dissolution of biologically formed minerals relates more to the process of remineralization, not mineralization. To summarize, mineralization is fundamentally about the recycling of elements and nutrients that have already passed through the biological food web back into inorganic forms that can be utilized again in the ecosystem. Thus, the correct answer is option 1. If the Earth were to be twice its present radius, but with its density reduced to half its original value, then 1. Its mass and gravity field would remain the same. 2. Its mass would increase 4 times, but its gravity field would remain the same. 3. Its mass and gravity field would increase by 4 times. 4. Its mass would remain the same, but the gravity field would increase 4 times. The correct answer is, its mass would increase 4 times, but its gravity field would remain the same. Let me explain. The mass increases by 4 times due to the volume increase, which is 8 times, and the density decrease, which is halved. The gravitational field remains the same because it depends on mass and radius, which balance out in this case. Water having total dissolved solids, or TDS, in the range of 1,000 to 10,000 milligrams per liter is classified as 1. Fresh, 2. Brackish, 3. Saline, 4. Brine. The correct answer is brackish. Here's why. Classification of water by TDS is as follows. Fresh water has TDS less than 1,000 milligrams per liter. Brackish water has TDS ranging from 1,000 to 10,000 milligrams per liter. Saline water has TDS greater than 10,000 milligrams per liter, but less than 35,000 milligrams per liter. Brine has TDS greater than 35,000 milligrams per liter. In this case, with TDS in the range of 1,000 to 10,000 milligrams per liter, the water is classified as brackish. In an urban polluted atmosphere, during what time of the day does ozone concentration peak? 1. 5 a.m. to 7 a.m. 2. 2 p.m. to 4 p.m. 3. 6 p.m. to 8 p.m. 4. 9 a.m. to 11 a.m. The correct answer is 2 p.m. to 4 p.m. Here's the reasoning. Ozone is formed by the photochemical reaction of sunlight with pollutants such as volatile organic compounds, or VOCs, and nitrogen oxides, or NOx. As sunlight intensifies during the day, these reactions increase, leading to higher ozone concentrations in the afternoon. Thus, the highest ozone levels are typically observed between 2 p.m. and 4 p.m., when the conditions for ozone formation are optimal due to the combination of sunlight and pollutants. Choose the correct sequence of rivers arranged in the order of increasing length. 1. Godavari, Kaveri, Mahanadi, Krishna. 2. Kaveri, Mahanadi, Krishna, Godavari. 3. Mahanadi, Krishna, Godavari, Kaveri. 4. Krishna, Godavari, Kaveri, Mahanadi. The correct answer is Kaveri, Mahanadi, Krishna, Godavari. Let's break it down. The lengths of the rivers approximately are as follows. Kaveri is about 765 kilometers. Mahanadi is about 851 kilometers. Krishna is about 1,400 kilometers. Godavari is about 1,465 kilometers. Arranging them in order of increasing length, we get first, Kaveri at 765 kilometers. Second, Mahanadi at 851 kilometers. Third, Krishna at 1,400 kilometers. Fourth, Godavari at 1,465 kilometers. Thus, the correct sequence is Kaveri, Mahanadi, Krishna, Godavari. In Orgeat, how many oxygen atoms of each SiO4 tetrahedron are shared with other tetrahedra? Is it 0, 2, 1, or 4? The correct answer is 2. In the structure of Orgeat, which is a type of pyroxene, each SiO4 tetrahedron shares 2 oxygen atoms with adjacent